there's this ramp that looks like this. And there's a guy at the bottom of the ramp, and he wants to run up that ramp. Well, if he manages to run up that ramp, he's going to move in two ways. He's going to rise up, and he's also going to run to the right. And that's what a slope is. A slope is how much he rises for every bit that he runs. So it's the rise over the run. And we look at that in math. We usually use a grid like this with two lines. Each line is called an axis. And this here we normally call the x-axis. X-axis. And that's the run. That's the left and right. And this one here we call the y-axis. Y-axis. And that's the rise. So suppose we had two different points on this coordinate system. Here's one, and here's another. Kind of looks like that ramp that we ran up earlier. So if we wanted to find the slope of that line, we would look at the rise, and we look at the run. And the way we do that is we look at the change in y over the change in x. And in the next videos in this series, we're going to explain exactly how to do that. Stick around. Alright, let's do a quick recap. So last time we looked at a guy going up a ramp, and we said he moves in two directions. He rises up and he runs to the right. And we related that to the coordinate system, and we said the x-axis is like the run, and the y-axis is the rise. Finally, we said that the slope equals the change in y, or the rise, over the change in x, the run. So let's do an example here. Let's draw our coordinate system, and we'll put 2 points. We'll say point A is at the coordinates 1, 2. So we go to the right 1, we go up 2, and we'll call that point A, 1, 2. Point B will be at coordinates 4, 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So point B will be right there. Coordinates 4, 5. Now we'll connect those points with a line, and we'll calculate the slope. So now the slope we normally call m. So m is the slope. And that'll be, we'll use our formula here, the change in y. So we look at the y values. B has a y value of 5. A has a y value of 2. So 5 minus 2 over the x values, the run. B has an x value of 4. A has an x value of 1. So 4 minus 1. Let's see, 5 minus 2 is 3. And 4 minus 1 is also 3. And 3 divided by 3 equals 1. So the slope is 1. And that means for every bit that we go to the right, that's our run. Every bit that we go to the right, we go up 1. So we go right 1 unit, and we go up 1 unit. So that's the slope of this line. If you're enjoying this series, give a like and a follow, and I'll see you for the next one. Now that we know that the slope equals m, which equals the change in y, which is the rise, divided by the change in x, the run. Let's look at some different types of slopes. Take a look at this one. Notice that as the run increases, the rise also increases. So we have positive rise over positive run, which equals positive. So that slope is positive. How about this one? When it goes down like this, the run increases and the rise decreases. So we have negative rise over positive run, and that equals a negative slope. Now how about this one here? This one's like that. So this, as the run increases, the rise doesn't do anything. There's no rise. So 0 rise divided by positive run equals 0. So that slope is 0. Now this one here is interesting. This one's vertical. Now this one has no run. And the rise, we don't know if it's going up or down. So this one, we don't know what the rise is. And the run is 0. And we know that we cannot divide by 0. So this one is undefined. Pass me a like and follow for more. One interesting way that we can use a slope is to look at the slope-intercept form of a line, and that looks like this. Y equals, remember m is our slope, x plus b. And b here is a y-intercept. Now remember, the y-axis is this guy, also known as the rise, and the x-axis is the run. So let's look at an example to illustrate how this works. So let's say y equals 3, x plus 2. Okay, so now what we're going to do is we're going to look at that y-intercept. Remember, that's b. In this case, it's 2. So the y-intercept is going to be on the y-axis, and we're just going to go up 2. So 1, 2. And right there is that point. And that's the y-intercept. Let's label that. That's 1, oops, that's 0, 2. The y-intercept will always have, it'll always start with a 0 because the x-coordinate is always 0 because it's on the y-axis. Okay? And then, so now we'll use the slope. That 3 there, what does that mean? Well, remember, the slope is the rise over the run. So that tells us that it rises up 3 units for every 1 unit that it runs. So starting from our intercept, let's go to the right 1, and then let's go up 3. 1, 2, 3. And let's plot that point. So we're going to go to the right 1 from our point, and then we'll go up 3. So there it is. And that'll be, that coordinate is 1, 1, 2, 3, 4, 5, 1, 5. So that's how we use the slope-intercept form to plot a line. Pretty cool. And we can even check right 1, up 3. All right. Follow for more. Last time we talked about slope-intercept form. And that looks like this. Y equals m x plus b. And m is the slope, and b is the y-intercept. So now let's talk about the point slope form. And this one goes like this. Y minus y1 equals m, which is again the slope, times x minus x1. Now what are these x1 and y1? Those are just particular coordinates. So for example, we can say x1, y1 equals 2, 1. And we can say the slope equals -3. So the purpose of having these different forms, we have the slope-intercept form, the point-slope form. You use whichever one is more helpful to you, depending on the context. Sometimes you have a y-intercept, sometimes you don't. Sometimes you have a particular point, sometimes you don't. So you use whichever formula is more helpful. So let's look at our example here. Let's plug this stuff in. So we say y minus y1. Remember we said that's, in this case, y1 is 1. Y minus y1 equals m. We said our m is -3 times x minus x1. And x1 in this case is 2. So that's 2. That's very sloppy. X minus 2. Okay. And now we just simplify. So we can take this out of the parentheses, y minus y1 equals, and then we can distribute. Distribute that. That's -3x plus 6. And then we can, let's see, we can add the 1 to both sides, and we get y equals -3x plus 7. So now we have it back into the slope-intercept form. Here's the slope, and here's the y-intercept. Okay, hope that's helpful. Like, follow, share, comment, all that good stuff. I'll see you for the next one. How do you find a parallel or a perpendicular line? Well, let me show you. It has everything to do with slope. Parallel lines look like this. They never cross, ever, no matter how far they go. They have the same slope. So m parallel, the slope of the parallel line, equals the slope of the original line. Now how about perpendicular? Perpendicular lines look like this. They cross at 90-degree angles. So the slope of the perpendicular line equals -1 over the original slope. It's a negative reciprocal. So let's do an example. Let's look at what we're given. We're given a slope 2 and a point 1, -3. Now recall the point slope formula. Y minus y1 equals m, x minus x1. Check out my earlier videos in this series if you are unfamiliar with that. So let's plug in what we're given. So y plus 3, since it's negative, equals m. So m is 2, x minus 1. That's the one there. Okay, distribute. Y plus 3 equals 2x minus 2. Subtract 3 from both sides. Y equals 2x minus 5. And that's our original line. Good, so now let's find the parallel line. That's this one here. Same formula. So y minus 2 equals m. Now remember, m parallel equals m, and m is 2. So that's just 2 again. 2 times x minus 4. Okay, we distribute. 2x minus 8. Add 2 to both sides. Y equals 2x minus 6. So that's our parallel line. How about perpendicular? Okay, same formula again. So y minus 1 equals m. So now m perpendicular, remember, is negative 1 over m, and m is 2. So that's negative 1/2 times x plus 2, since this is a negative 2. Okay, distribute. Y minus 1 equals negative 1/2 x minus 1. Add 1 to both sides. Y equals negative 1/2 x. There we have it. We found a parallel and a perpendicular line, and we got them into slope-intercept form as well, and that looks nicer. Okay, hope that helps. Thanks for watching. Can you find the slope just by looking at a graph? Let's give it a shot. Let me tell you, first of all, when you do these problems, a lot of times you are estimating because you can't tell exactly where the points are. But here, the graph is pretty clear. It looks like there's a point at 1, negative 3, and another point at the origin, 0, 0. So let's remember the formula for a slope. So slope equals m, which equals the change in y, or the rise, over the change in x, or the run. So let's plug these numbers in. So we have, for the change in y, we have negative 3 minus 0. So negative 3 minus 0 over 1 minus 0. 1 minus 0. Okay, so what does that equal? That's negative 3 over 1, which equals negative 3. So that's the slope. Now there's an easier way to do this when the graph is this clear. What you do is just, you go over 1 unit. You do 1 unit of run. So we go from 0 to 1. So for every 1 unit of run, what is our rise? Well, in this case, we go down 3. So it's that simple. The slope is negative 3. All right, thanks for watching. Can you use the slope to solve this problem? Let's give it a shot. So let's remember that the slope equals the change in y over the change in x. So let's decide what we want to be y and what to be x. Let's say y is the distance and x is the time. And let's just plug those into our formula. So we're told that the car travels, it increases from 40 to 100 miles. So we just do 100 minus 40. And it says it does this in 2 hours, so 2 minus 0. Let's solve that. We just get 60 over 2. And that equals 30. So the slope, we usually call the slope m. So m equals 30. And let's interpret that. So we have time in hours, and over that we have distance in miles. So this is 30 miles per hour. Okay, so now we know that slope is not just something that you can look at on a graph. It has real-world applications. But let's go ahead and graph it just for fun. Let's say this is our x-axis, which is time. Our y-axis is distance. And let's plot this thing. So at 0 hours, it is at 40 miles. So that'll be, we'll call that 040. And then at 2 hours, it is at 100 miles. We'll say that's 100. So let's connect that line right there. That line segment is, it shows the car traveling in terms of miles per hour. And the slope there is 30. All right, hope that helps. Thanks for watching. Which line is steeper, and how can you tell? Let's say we have y equals 4 over 3x plus 1, and we have y equals negative 2x plus 3. Which one is steeper? Well, let's see. The slope of the first one, we'll call that m1 equals 4/3. And the slope of the second one, we'll call that m2. That's the wrong color. m2 equals -2. So the sign tells the direction. So the first one, m1, rises up, and m2 falls down. But steepness is about how big the number is. That's why we use absolute value. So let's see. Absolute value of m1 equals 4/3, and that is approximately 1.33 if you put that in a calculator. m2, let's see, the absolute value of m2, well, what does absolute value mean? It means ignore the sign and just keep the size. So that tells us how strong the tilt is rather than which way it leans. So m2, the absolute value of that, equals 2. So 2 is greater than 1.33. So line 2 is steeper, even though it slopes downward. So just remember that slope 1, it goes up 4 for every 3 right. 4/3, right? So 1, 2, 3, 4. 1, 2, 3, 4. For every 3 right. 1, 2, 3. And m2 goes down 2 for every 1 right. So 1, 2, and 1 right. Okay, hope that helps. Thanks for watching. Here's everything you need to know about slope. So the formula for slope, we call it m. M is the change in y. Change in y, or we call that the rise, divided by the change in x, which we call the run. Now there's different types of slopes. If your slope looks like this, then the slope m is positive. If it looks like that, it's negative. If it looks like this, it's 0. And if it looks like this, it's undefined. All right, so let's look at the 2 different forms of a line that involve the slope. So there's slope-intercept form, y equals mx plus b. So there's our slope, and b here is the y-intercept. That's where the line crosses the y-axis. The other form is the point-slope form, which is y minus y1 equals m times x minus x1. There's our slope again. And then x1 and x2, those are the coordinates for a point. I'm sorry, x1 and y1, those are the coordinates for a point. Okay, so those are our 2 line forms that involve the slope. And then how about steepness? So if we want to see how steep a line is, we look at the absolute value of the slope. That means we don't care if it's positive or negative, we just look at the absolute value. And if that is bigger, that means the line is steeper. Okay. What else? Let's look at some geometry. So this is the symbol for a parallel slope. So if a line is parallel to another line, then m parallel equals m. They have the same slope. Okay, but if 2 lines are perpendicular, we use this symbol for perpendicular. M perpendicular equals -1 over m. So it's the negative reciprocal. Okay, so now in the real world, what are slopes for? So anytime you hear per, there's a good chance that slope could be involved. So like miles per hour, dollars per day. So the line is the pattern, and the slope is how it changes. All right, hope that helps. Thanks for watching.